3.2. Rolle's theorem and the mean value theorem. There are two more theorems associated with extreme values, Rolle's theorem and the mean value theorem, or M.V.T. Rolle's theorem states that if the function f is continuous on the closed interval from a to b, f is differentiable on the open interval from a to b, and f of a equals f of b, there must be at least one c value such that f prime of c is 0. Let's look at this on a graph. If this is the function f and f of a equals f of b, we can see that at some point the slope of the graph must equal 0 at some maximum or minimum. This connects back to the extreme value theorem, which states that there must be some maximum or minimum on a continuous interval of a graph. Let's try some practice problems using this theorem. First, we have to be able to determine if Rolle's theorem can be applied. In this first example, since f is undefined at x equals -3, because this is where the denominator is 0, the function is not continuous within the interval from -4 to 0. Therefore, Rolle's theorem cannot be applied because it does not meet all the requirements. In the next example, f of x is continuous and differentiable, but f of 1 does not equal f of 3, because we can see that f of 1 in this case is 0, while f of 3 is 2. Therefore, f of 1 does not equal f of 3, and we can say that Rolle's theorem may not be applied. In the third example, we can see that since this function is a polynomial, that makes it automatically continuous. This is a property of polynomials that's useful in the future. This polynomial is also automatically differentiable. Now we must check the endpoints to make sure it satisfies the third criteria. F of -2 equals 8, and f of 2 also equals 8, making f of a equal to f of b. Therefore, Rolle's theorem does apply. We can also find the c value mentioned in Rolle's theorem. Continuing the previous example, we've already verified that the function meets all three conditions. Now we have to find a value of c such that f prime of z is 0. To do that, we will take the derivative and set it equal to 0, then find the value of x causing the slope of the function to be 0. When we take the derivative, we get 4x cubed minus 4x. Setting equal to 0, we can factor out a 4x to obtain 4x times x squared minus 1, which can be further simplified into 4x times x plus 1 times x minus 1, giving us x values of 0, -1, and +1. All three of these are within the given intervals, so therefore our c values are 0, -1, and 1. Let's move on to the mean value theorem. This states that if a function f is continuous over the closed interval from a to b, and also differentiable over the open interval from a to b, then there must be some value c such that f prime of c equals f of b minus f of a all over b minus a. In other words, there's some point at which the instantaneous slope equals the average slope over the interval. Looking at this on a graph, as we can see, the graph slope must equal the average slope at some point in the interval. There's a process to using the M.V.T. in a problem. First, find the average slope by using the formula f of b minus f of a all over b minus a. Next, find the derivative in terms of c. Finally, set the average slope found in step 1 equal to the derivative equation from step 2 and solve for c. Let's try a few examples. In this example, we first have to check that the function is continuous. Well, the graph is undefined at x equals 0, but this isn't in the interval, so we can disregard, and the function is differentiable everywhere. Alright, the first step is to find the average slope. In this case, f of 1 is 1, and f of 4 is 4, so we can see that the average slope is simply 4 minus 1 over 4 minus 1, giving us an average slope of 1. Moving on to the second step, we have to take the derivative. We can rewrite y as y equals 5 minus 4x to the -1 to make it easier to use the power rule. Taking the derivative, the constant disappears, and we can move the power down to obtain 4x to the -2. Now we can just plug in c to get y prime at c 2 equal 4 times c to the negative 2. Finally, we have to set the two slopes equal to each other. 1 equals 4 times c to the negative 2, and we can rewrite that as 1 equals 4 over c squared. Moving the c squared to the other side, we get c squared equals 4, so c equals 2 and negative 2. However, negative 2 is not within the interval from 1 to 4, so that is not our part of our answer. And our answer is c equals 2. Let's try another example. First, we have to check if the M.V.T can be applied. We can see that the function is undefined at x equals 0 because that's where the denominator is 0. Since x equals 0 within the given interval, we cannot use the M.V.T. Always make sure to check if the M.V.T can even be applied before trying to solve a problem. Here is yet another example. This time, since the function is a polynomial, we can automatically say it's both continuous and differentiable. Moving on to solving the problem, we must find the average slope, which in this case is f of 6 minus f of 0, all over 6 minus 0. F of 6 is 900 and f of 0 is 0, so we get the average slope is 900 minus 0 divided by 6 minus 0, which comes out to be 150. As for the derivative, by moving the power down and subtracting it by 1 for all of these terms, we get 4x cubed minus 6x squared plus 2x. F prime at c is equal to 4c cubed minus 6c squared plus 2c. When we set f prime at c equal to 150, which in this case is 150 equals 4c cubed minus 6c squared plus 2c, we get that c equals 3.872 by using a graphing calculator. And that's our answer. Let's try an AP problem. This problem says, the function f is continuous on the closed interval from negative 2 to 2, and f of negative 2 equals f of 2 equals 0. If there is no c, where c is on the open interval from negative 2 to 2, for which f prime of c equals 0, which of these following statements must be true? Well, we can notice that in this problem, f of negative 2 equals f of 2. This means that we must be using the ROLLE'S theorem. The two conditions for ROLLE'S theorem is that a function must be continuous and that that function must be differentiable on the interval. In the problem, we already know that the function is continuous, so we know that the function must not be differentiable for f prime of c to not equal 0 at some point. Looking at options A and B, we do not know what value the derivative is at any point. So we cannot say that those two statements are true. Option C states that f prime at k exists. However, if this was true, the function would be differentiable, which isn't possible. Therefore, both C and D are eliminated. That leaves just option E, which states that f prime at k does not exist at some point. That means that the function is not differentiable at some point, which corresponds to our inferences from before. So E is the answer. This next AP problem states that the function f is continuous on the closed interval from negative 2 to 1 and differentiable on the open interval from negative 2 to 1. If f of negative 2 equals negative 5 and f of 1 equals 4, which of the following statements could be false? Well, we could notice that since the function is both continuous and differentiable, we can use the M.V.T. Let's find the average slope. The average slope is equal to f of 1 minus f of 2 all over 1 minus negative 2. Therefore, that's equal to 4 minus negative 5 all over 1 minus negative 2, giving us 9 over 3, which is 3. Therefore, we know that at some point C, the derivative of the function must be 3. Looking at our options, option D fits this, so it must be true. Therefore, we can eliminate it. Moving on, let's draw a basic sketch of the graph based on the information we know. We know that f of negative 2 is equal to negative 5 down below, and that f of 1 is equal to 4. Since the graph must be continuous, we know that it must pass 0 at some point. Therefore, option A must be true. Similarly, for option C, the graph must pass 3 at some point, so therefore we can eliminate option C as well. Now, let's look at option B. This states that at some point C, f prime of C equals 0. However, we know that this is a Rolle's theorem concept, not for the mean value theorem. And since f of negative 2 does not equal f of 1, we can't use Rolle's theorem. Therefore, B must be false. So that's our answer.